Well, hello everybody. We're back for part B of this. I hope that it's starting to make more sense to you now. So let's begin. Instead of just doing elements, we're going to do compounds with genuine formulas. So let me make this gigantic and let's begin. So what we want is the mass of a compound in grams that equals the mole amount of that compound. So, essential questions. How do I know how many grams are in a mole amount of a compound? How do I know the correct formula for the compound? We know that. And what's an easier mathematical calculation method available in OneNote? And you know, we've used it before where we simply write out a little equation easily and it does the calculation for us. This is the lesson that is the most useful for. All right, so we saw that elements on the bottom of the periodic square have an average mass value, and it's never a whole number. It seldom is, I should say. This one's for sodium 22.99, chlorine 35.45. This is the average mass of an atom of chlorine and average mass of an atom of sodium. And remember, we were talking about the fact that it's the average mass based upon the isotopes of sodium that all have 11 protons, but some of them have different numbers. They have different numbers of neutrons. So now we have this compound of NaCl, and we know that's the right formula, -1 + 1, so 1 of each. All right, it says 1 mole of sodium chloride can be shown in 2 ways. Its formula is NaCl. The mass of 1 compound unit, which the formula shows you. All right, set up the calculation and OneNote automatically calculates it. So for this example, I went to sodium and I put 1 times, and this is the asterisk instead of the X in OneNote, times 22.99 plus 1 times chlorine, 35.45. And remember that the reason there's 1 of each is because NaCl is like Na1Cl1. All right, then we put an equal sign and press enter, and it calculates us automatically. And this is the number of grams. This is the number of grams in a mole. You know, all of the particles we could use in the laboratory area, or this is the number of atomic mass units that 1 particle of NaCl it would mass out. All right, and remember the reason that this is important, what we're doing today, is we can't work in the lab with particle amounts. They're way too small. We can't measure them. But we can measure mole amounts on a balance, and that's why this number on the bottom of the periodic table in grams is so useful, because we can measure out 22.99 grams of sodium. All right, so what does this number mean? Well, let's put it in sentences. The mass of 1 mole of sodium chloride is 58.44 grams. All right, so we're calling that a mole amount. There are 6 times 10 to the 23rd NaCl units, a particle, in 1 mole of sodium chloride. So instead of talking about 1 particle, we're talking about 6 times 10 to the 23rd particles that make up this mass of 58.44 grams. All right, and that's what the third statement says. All right, and so over here I showed you what I was doing here. Let me put this over here, that NaCl is made up of a sodium and a chlorine ion, and an electron is transferred from one to the other. All right, and 58.44 grams is the amount of salt in, and that amount of salt has 6 times 10 to the 23rd salt particles in it. Now, here's another example with magnesium chloride. We know its correct formula is MgCl2, because as you remember when we were learning this, we were using the ionic charges. Magnesium +2, and chlorine has a -1 charge, and we needed 2 of those. Then we have +2 - 2 = 0, and we know MgCl2 is the correct formula. So, we're trying to find, it looks like I have a typo there. All right, we're going to set up the calculation then to figure out what is the mass of an MgCl2 particle. So there's 1 magnesium, so 1 times 24.31 plus 2 times, since we have 2 chlorines, 35.45 equals, press enter, and OneNote calculates it at 95.21 grams. All right, this is an amount we can measure out in the laboratory. All right, and in that amount that we can't see are 6 times 10 to the 23rd MgCl2 particles. All right, so do you see how we're going from the atomic level thinking to the lab level of thinking in this? And what good is chemistry if we can't do experiments at the lab level where we live? But what good is chemistry if we can't explain what's going on at the atomic level? So you see there's a strong necessity for having a mole amount and a particle amount. All right, so in summary, the amount of grams of 1 mole is called the gram formula mass because it's the mass of the formula MgCl2. But it's also called the molar mass because it's the mass of 1 mole, isn't it? All of these mean the mass of 1 mole of a substance. And in that, there's 6 times 10 to the 23rd formula units. That is, the formula is MgCl2. So there's 6 times 10 to the 23rd of those little MgCl2 units in the mass of 95 grams. All right, so that's what you were doing down here when you were calculating this. So I think some of you found this wasn't very difficult, and others of you thought, well, I guess I can see what you're doing, but I don't know why it's even important. All right, so the importance is what I'm trying to get across to you, that this is worth knowing. All right, so let's just do some fancy typing here. With KBr, this is the correct formula. So in all of these, I gave you the correct formula. So we're just trying to figure out what the mass would be of 1 potassium atom and 1 bromine atom. So 1 times 39.20, which is on the periodic table, and 1 times 79.90, the mass of a bromine atom, equals 119.1 AMU. So that's the mass of 1 particle. But if we have a whole mole amount, it's equal to 119.1 grams. And we could measure, that's kind of a large amount, but we could measure that out on our balance. All right, so that's the number of grams in 1 mole. And you can see how grams divided by mole is the way to express that unit. All right, so if we have the formula, it's easy to get a gram formula mass by simply adding up the number, adding up the elements. How many do we have of each kind? So here we have water, a covalent compound. We have 2 water atoms, so 2 times 1.008, see how from the periodic table, plus 1 oxygen atom, so 1 times, let's go over and look, oxygen 16.00. All right, right now we're using this periodic table because I don't have one of ours at home. But whatever table we're using, we just use the numbers that are on the bottom of the screen. We don't round them. All right, so when I did that, put an equal sign and pressed enter, I got 18.016 as the number of AMUs in 1 particle. And if I put grams here, an amount we can see and measure out, that means that's the amount in 1 mole of it, or 18.016 grams per mol. All right, of water. Now, I want you to do the same thing now with these. So some of you didn't get this far because you were doing the testing, the science testing. So I want you to go ahead and do these. Some of you that are sophomores probably did do a pretty good job. All right, so let's just do some practice. So carbon, let me make this smaller. And you can do the same thing. Remember, these are just pictures and things that you can adjust on your assignment. All right, so let's go see carbon, 12.01. We have one carbon atom, 1. I go to the asterisk, 12.01 plus 2 times 2 asterisk 16.00 for oxygen equals, enter. It says there's 44.01, and these are the number of grams in 1 mole amount of carbon dioxide. All right, that means there'd be 6 times 10 to the 23rd of these CO2 particles. Secondly, let's go down here. It says there's 2 aluminum atoms in this correct formula and 3 oxygen. So I'm just going to put 2 asterisk. Aluminum is 26.98 plus 3 times 16.00. I want you to see how fast this is going. Remember, multiplication and division will be done first before addition and subtraction. So even though I'm not using parentheses, this works. When you find out it doesn't work, it means you probably need to use some parentheses. So this is the number of grams in 1 mole of aluminum oxide. All right, now, here we have 1 sodium, 1 oxygen, 1 hydrogen. So go ahead, 1 of each. So we don't have to put 1 times each one, now that you know that. So sodium 22.99 plus 16.00 plus 1.008 for hydrogen equals, enter, and 39.998 grams in 1 mole of sodium hydroxide. Do you see how fast we're speeding along with this? All right. So now N2O5 looks complicated, but when we calculate it, we just put 2 times nitrogen, which is 14.01, plus 5 times, using an asterisk, 5 times 16.00, 108.02. Nothing is difficult when you let OneNote do the math for you, all right? You just have to use the right characters. This is the number of grams in 1 mole amount of dinitrogen pentoxide, right? Dinitrogen pentoxide, something we did last week. All right, so doing all of these, you can now see how easy this is to do. All right, down here I showed you when we have an NO3, do you see how I put 1 barium, 137.3, plus this 2 here, 2 times, and then nitrogen 14.01, plus 3 times oxygen 16.00. I put this in parentheses, equals, and then put grams per mole of barium nitrate. And grams per mole, and this is an amount of barium nitrate. Do you see how we're putting together everything we've learned? This is when I think you should be thrilled, all right? So, do I ever teach you something that we don't use again? Hardly ever. So we keep hitting things over and over and over again, and that's one of the reasons I love chemistry so much. It's intricate, but I'm showing you all the ways in which it fits together. So down here with aluminum, we would be doing the same thing. Aluminum has a mass of 26.98, and there's just one, 26.98, but we have 3 of those NO3 units. So plus 3 times, and you have to put the asterisk. All right, now we put 14.01 plus 3 times oxygen, 16.00. Then we add the parentheses again because we're 3 timesing this little unit, equals, and enter, and it calculates for you that that's the number of grams in a mole amount of aluminum nitrate. All right, that's all there is to this. Yeah, at first it seemed odd because we hadn't done anything like that. All right, now I want you to think through something else. All right, here we said that there's 213. So let me just copy this. All right, copy. It just doesn't want to do that. All right, copy that. All right, so this is the amount. $213 grams in a mole amount. It says how many grams would be in half of a mole. Well, 1/2 times 213.01 equals, let's see if it will calculate. Yeah, grams in a half mole amount. All right, I want you to do the same thing down here. And I want you to see how this isn't horrible. That this is actually just reasoning through. If you have 1 whole mole amount, it's 213. But if you have half a mole, well, it's half of 213. All right, and you can do that. All right, so finish this up. And I'm going to be impressed when I look at your papers. All right, I'll talk to you later. All right? Anxious to see you again. Bye.